Hello, Algebra 2 students. We're talking today about section 1.2 and algebraic expressions. Basically, an expression is when we're going to combine a number of letters, variables, numbers, algebraic operations together to make a phrase. And so we just want to go through some terms first. First of all, a variable, usually a symbol, usually a letter, obviously, that represents one or more numbers. Examples of variables, very simple. You could have the letter, anything like A, B, C. The most common variable of all, generally used, X or Y. You could have a variable, perhaps like, that was a Greek variable, something, a symbol like that, like delta. So it could be just about anything. It could be a box. That could be a variable representing something. But generally, we're going to use things like X or Y. An algebraic expression, in comparison, is when we take a bunch of variables and numbers and algebraic operations like plus and minus, and we combine them together. Things that were simple like 2a plus 1, or 4xy, or things that are more familiar to you, say pi r squared, pi being a number. Or you could have the volume formula of a cube, 1/3, base times height. You could have just about anything, a squared plus b squared. Now, what you will notice about each of these things is they don't have an equal sign. They're not an equation, they're just an expression. And then lastly, when we evaluate, evaluate means we're going to substitute numbers in for the variables, and we're going to follow the order of operations and define simply the value of that original expression. Now, one of the important things I want to emphasize is when you substitute in, I want you to really work hard on remembering to replace the variables with parentheses. So, when we replace the variables with parentheses and stick a number then in there, it allows us really to avoid making mistakes. And so that's something I really want to focus on as we're working through our evaluation problems, is always using parentheses to do so. So let's try to evaluate these couple problems here. Now, for these problems, we need to make aware of the fact that x equals -2, y equals 5 for each of these problems. So here we go. We're going to take 7 with a parentheses, -3, and a parentheses for y. Then we're going to put in the values of -2 for x and a +5 for y. We're going to continue to work this problem and get -14. And then we say -3 times -2 is 6 times 5 is +30. Adding them together, our final answer is 16. So, no equal signs in the problem, but we evaluated by plugging in. Let's try our second one. Parentheses for k, -18 squared minus 4k. So 4 parentheses. We're going to put our value in. K is 6 in each case. And our inside, we're going to say 6 minus 18. 6 minus 18 is -12 minus 24. -12 squared, I hope you're realizing that the negative is being squared as well as the positive, so -12 squared is going to be 144. Minus 24, very simply, is 120. 120. Not 120, but 120. Our third problem here is we're evaluating when x equals a -2. Remind yourself, x being a -2 makes a big difference and makes a big impact, as we have to consider what happens when we're dealing with that negative. So let's take a look. We have 4 parentheses -3 over 3 minus 3 parentheses -4 over 3. We're going to put the value -2 in to each of our problems. That's -8 minus 3 over 3 minus -6 minus 4 over 3. That's -11 over 3 minus -10 over 3. Hopefully you see that minus a minus means we're going to have a plus 10 over 3, giving us a minus 1/3 as an answer. It seems to me that that's a lot of fractions that we've been dealing with. And I want to ask ourselves, is there an easier way to look about and solve the problem? Well, if I was thinking through this and I was saying, we have a common denominator already, what if we just distribute the negative sign to the second fraction, and then we try to combine before we simplify? Well, we've got 4x minus 3x is x, and negative 3 plus 4 is a plus 1, all over 3. Now we can evaluate. Parentheses plus 1 over 3. Stick in the value negative 2, and we get negative 1/3 as an answer. I'm going to let you be the judge of whether simplifying first is a better option or working a problem out before we simplify. I think you and I both know that the best choice is simplify first as we work through our problems, and that is going to be a better choice all around. Let's take a look at our next page. Algebraic expressions can be broken down into terms. Each term is separated from another term by a plus or a minus. So, in this following example to the right, you have two terms, 7x squared and 3y. The coefficient, as you can see, highlighted in blue, are the numbers in front of each of the terms. Like terms are terms that have the same variables and also the same powers. So all of the following would be considered like terms. 4a squared b, 6a squared b, negative 9a squared b, and a squared b, because in each case they all have an a squared and a b, but the coefficients out front are all different. Just as a sidebar, please remember that there always is an invisible 1 when you don't have a coefficient out front. So, in our example 3, we're going to try to simplify the like terms. Remember, like terms are terms that have the same variable and the same exponent. Our first example we're going to look at, first we're going to need to distribute that 7 outside the parentheses. That gives us 14h and minus 21k. Our like terms that we're identifying is first my h's, that gives me 16h, and then second my k's. That gives me negative 21k. So that's our simplified expression, realizing that we did do it alphabetical and work it through that way, h before k. Let's slide over and take a look at b. We're going to distribute the y to both parts, and we're going to get y plus y squared minus 3y squared. And now we're going to distribute this invisible negative 1 into both of the back parts, giving me minus y minus 1. I'm going to underline my y squareds with 2 lines. That's going to give me 2y squared. I'm going to switch colors to my y's and underline them with 1 line. Y minus y is gone. And then finally I'm going to put a dot under my constant, and I'm going to realize that that is a minus 1, giving me a final summary of negative 2y squared minus 1 as my answer. Let's slide over here and look at C. The biggest challenge on this problem is going to be distributing before we combine. Once again, realize you have a minus 1 out front that you're going to need to distribute, and then we'll also distribute the minus 2. Here we go. Negative 2x minus y plus 2x plus 2y. What are my like terms? Well, here's my x's, and they are additive inverses. That means they drop out to 0. So all that I really have left to combine are my y's. And negative y plus 2y is simply 1y as a result. Let's take a look at this problem at the bottom that discusses the idea of perimeter. We're given a figure that has multiple sides with a concave section cut out with dimensions b by b by b. We're asked to find the perimeter. Very simply, that means we're going to add up all the sides. So as I circle a side, I'm going to write it down. So a plus 2a plus 3b plus 2a minus b over 2 plus another 2a minus b over 2. So there's our perimeter. Let's simplify our like terms. In front we have 4a plus 3b plus a common denominator gives us 4a minus 2b over 2. Let's simplify by dividing each by 2. That's 2a minus b, giving us a final answer of 6a plus 2b. And that would be our perimeter. So as we kind of look at our material here, we have to understand that we've got a lot of things to consider with perimeter that we're going to work on. But let's go back to the beginning and let's do a little quick review before we finish up. We talked about variables being letters representing symbols and algebraic expressions being multiple different possibilities with both letters, numbers, and exponents. We talked about evaluating being the importance of replacing variables with parentheses and then sticking in the numbers to get down to one simple value. We reminded ourselves about using parentheses and putting them into a problem to make sure that we don't make simple errors. We also reminded ourselves that sometimes it's easiest to simplify first before we evaluate to make a problem easier. Then we reminded ourselves about like terms having the same variable and the same exponent. Distributing a negative came up a couple different times, and paying attention to distributing that negative before we combine our like terms. And then lastly, finding the perimeter of an object, being careful that we're identifying all the different parts and we're adding them together carefully as we work through our problem. I hope this has been informative to you, and I hope the homework will be a simple process for you as you continue to work through this material.